So there's been a huge push for things like AI and cloud computing, enabled by these massive data centers that you may have heard about in the news. And along with all of the high input power and compute that's required for these applications, we get a lot of thermal load that has to be rejected. And so the thermal management solutions that are currently out there, things like heat spreaders and heat sinks, are no longer up to the task.
Individual carbon nanotubes have extraordinarily high thermal conductivity, but the challenge has always been, how do we go from those exciting properties of one tiny nanotube to an outstanding thermal conductor at the macro scale? And that's what our colleagues here and collaborators at Rice have been working on for the past several decades. And right now it's really exciting that we can achieve thermal conductivities and properties that are comparable or even better than that of the thermally conducting metals like aluminum or copper that are utilized in thermal management applications.
This material has properties that overlap with carbon fibers, they overlap with Kevlar, overlaps with steel, overlaps with copper, overlaps with aluminum. And so you could now go and do anything that you're doing with those materials and do it at least the same or maybe even better with this new material.
We're working on making new high-performance heat sinks, heat exchangers with these carbon nanotube fibers. In our lab, we're able to go and structure these into devices. We use advanced manufacturing methods, including 3D knitting. Behind me, you see some 3D knitting machines, which we can scalably produce different devices, change the interlooped or entangled architecture locally, and be able to tune the performance, the thermal performance, the geometry, the mechanical properties, and it's all done additively, almost like printing off of a machine.
We're essentially building a new supply chain from the synthesis of high-quality carbon nanotubes through their transformation into intermediate fibers and fabrics to final functions, leveraging new architectures and designs. We are reimagining how we manage heat and energy. Because cost and scale are vital for adoption, our projects operate within the Carbon Hub, enabled by Rice's Advanced Materials, Small Liqueur, and Sustainability Institutes. Together, we are bridging the gap between lab-scale discovery and sustainable industrial impact.